Francis turbine. Francis turbine is a mixed-flow reaction turbine used for medium heads. It was the first hydraulic turbine with radial flow, designed by American scientist James Francis. The front and top views of a Francis turbine. It consists mainly of Francis turbine, head cover, water inlet, main shaft, operating ring, water guiding device, spiral case, guide vane, stay ring runner, draft tube, guide vane. Francis turbine consists of the following parts: runner, guide wheel, spiral casing, draft tube. First, runner. A runner is a circular wheel on which a series of curved blades are fixed. The number of blades usually varies between 16 and 24. The runner in turn is coupled to a rotating vertical shaft. Next, guide wheel. A guide wheel is a stationary wheel around the runner of the turbine. A number of blades are fixed around the circumference of the guide wheel, and these blades are called guide blades or stationary blades. The guide blades allow the water to strike at a certain angle onto the moving blades. The blades are designed in such a manner that the water, while flowing through the blades, will be subjected to nozzle effect. In other words, the pressure energy of the water will be converted to kinetic energy during its flow over the blades. Next, spiral casing, volute, or scroll casting. The spiral casing is a closed passage surrounding the guide blades. The cross-sectional area of the spiral casing gradually decreases, tapered along the flow direction in order to distribute water uniformly around the entire perimeter of the runner. The spiral casing is also known as scroll casing or volute. Next, draft tube. The draft tube is a tube or a pipe of gradually increasing area used for discharging water from the exit of the turbine to the tail race at low pressures. It does not allow water to fall freely to the tail race, as in the case of Pelton turbine. Working. In operation, water from the reservoir, dam, flows through the penstock and enters the spiral casing. As the water flows through the tapered spiral casing, a part of its potential energy is converted into kinetic energy. Water flows through the guide blades, gets deflected, and then flows radially inwards to the outer periphery, outer diameter of the runner. The water then moves over the moving blades in the radial direction and is finally discharged to the tail race axially from the center of the runner via a draft tube. During its flow over the runner blades, the blade passages act as nozzle, and the remaining part of the potential energy is converted into kinetic energy. It is important to note at this point that the jet of water does not impinge on the runner. In fact, they are leaving the runner at high velocity. So, the momentum is converted into force, as in the case of impulse turbine. Since the water leaves the blades at high velocity, there is a reaction force on the runner. This force sets the runner into rotary motion. Hence, the shaft connected to the runner also rotates, thereby doing useful work. The shaft in turn drives the generator to produce electricity.